Introduction to equilibrium of a particle. For a particle to be at rest, it must be in equilibrium. For a rigid body, if all the forces are acting at any common point on the body, it may be regarded as a particle. When a particle is in equilibrium, its resultant force is zero. In this lesson, you will be able to state the condition for equilibrium of a particle or a point mass, understand the concept of free body diagrams, and learn to solve problems related to equilibrium of a particle by using the condition of equilibrium for coplanar forces summation of F equals 0. Will a single force acting on a particle A give rise to equilibrium? Click 1 to know the answer. Click 2 and observe whether the particle is in equilibrium or not. When two forces F1 and F2, F1 is greater than F2, are acting in opposite directions. What is the condition for a particle to be in equilibrium under the action of two forces? Click 2 and observe whether the particle is in equilibrium or not. When two forces F1 and F2, F1 is greater than F2, are acting in opposite directions.
So that means that we notice that the force F1 is greater than F2. F1 is act from left to right. That means that F1 is greater than F2. That means that the object will move or accelerate to right. Accelerate with the same direction with the greater force.
What is the condition for a particle to be in equilibrium under the action of two forces? Click Answer. The particle is in equilibrium under the action of two forces only when the two forces are equal in magnitude and opposite in direction.
So this means that if the object is in equilibrium state, this means that the magnitude of the force are equal but are in opposite direction. So as a result, the acceleration of the object is equal to 0 and the object is in stationary because both sides of the forces with balance force.
Click 3 and observe three concurrent forces acting on the particle. The particle will be in equilibrium under the action of three forces if the vector sum of the three forces acting on the particle is 0 or if the forces form a closed triangle. Click on any of the two statements. According to the first statement, F1 plus F2 plus F3 equals 0. That is, summation of F equals 0. Click back.
So from here, the particle A or the object A is acted by three forces, F1, F2, and F3. So F1, F2, and F3 are in different direction. But no matter how, we can say that we have made the conclusion, the magnitude, the vector F1 plus with the vector F2 and the vector F3 all together will be equal to 0. So this means that we can say that the sum of the forces are equal to 0. So if the force from a cross triangle,
According to the second statement, the forces F1, F2, and F3 form a closed triangle as shown.
So we use the three, the three forces, three vector. So we arrange until it form a triangle. Actually, from here, we can form two types of the triangle. No matter how, if the object is in equilibrium, this means that they will just have single direction only. The triangle we can form, now we notice that F1, F3, and F2, they are in same direction, right? In one direction to form the cross triangle. And I also can rearrange the, I can rearrange the triangle. If the triangle form is like that, that means this is F1, and this will be my F2, and F3 in this direction. So this is the F3. At the end, I still get the in one direction again. So this means that this direction will be the clockwise direction, and this triangle will be in anti-clockwise direction. Clockwise direction and anti-clockwise direction show that the resultant force is equal to 0 Newton. If the system with zero resultant force, that means that the object is in equilibrium. When the object in equilibrium, the acceleration is equal to 0 ms negative 2. If an object with any vector or a resultant force, that means that the triangle will form, we just only complete with two directions. That means that from the triangle vector diagram, that means that this will be the direction, one direction, another direction will be in this direction. Both direction to form the cross triangle. So we said that this triangle with a resultant force. Now let's move to the next slide.
Observe the action of n number of forces on a particle. Click Answer to know the condition for the particle to be in equilibrium.
What happens if a system is at with 5 or more forces?
The forces should form a closed polygon. Summary. A particle refers to a point mass as well as a rigid body where the forces act at the same point on the rigid body. A single force acting on a particle will never give rise to equilibrium. For a particle to be in equilibrium under the action of two forces, the forces must be of equal magnitude and opposite in direction. For a particle to be in equilibrium under the action of three concurrent forces, the forces F1, F2, and F3 should form a closed triangle. In general, a particle under the action of any number of forces is in equilibrium if the forces form a closed polygon. A box of mass 60 kg is suspended by a rope of length 2 meters from the ceiling. Click the play button. Consider the equilibrium of the forces acting at a point P. What is the force F along the horizontal? Force F can be calculated by using both the vector addition method and by resolving forces in the x and y directions. Using the vector addition method, we can represent the forces W, F, and T by a closed triangle. Click Continue to follow the solution. From the first diagram, sine theta equals 0.50 over 1.00. Therefore, theta equals 30 degree. From the second diagram, tan theta equals F over W. Therefore, F equals W tan theta, which equals 60.00 times 9.81 tan 30 degree, which equals 3.40 times 10 to the power 2 Newton.
Using the alternative method of resolving forces, the sum of the components of the forces along the x direction is equal to 0, and the sum of the components of the forces along y direction is equal to 0. Click Continue to follow the solution.
The second method is use the resolution of the forces. So this means that the force which not in the horizontal and vertical component of horizontal and vertical direction, we resolve it into vertical and horizontal direction. This means the F, once we know that this T is formed by, we can resolve into the horizontal component and the vertical component. So this means that this will be T, the angle is here, right? So this means this will be T cos delta, and this side will be T sin delta. After we solve, this means that this force will not appear anymore in the system.
F minus T sine theta equals 0. Therefore, F equals T sine theta. T cos theta minus W equals 0. Therefore, W equals T cos theta. Dividing the equations 1 by 2, we get F over W equals tan theta. F equals W tan theta, which equals 60.00 times 9.81 times tan 30 degree, which equals 3.40 times 10 to the power 2 Newton.
If the object are in equilibrium state, that means that the force which are in opposite direction, they are equal to each other. For example, if this object is in equilibrium, that means acceleration is equal to 0. So what is it means? It means that the F, the force, total force to right equal to the total force to left. Total force up equal to the total force down. So to find the to solve the answer, to solve the question, F is going to right side. So T sin delta is going to left side. So F is equal to T sin delta because both of them are equal and cause the object in stationary. Total right equal to the total left. Total up T cos delta equal to the total force down. You see, total left, total right equal to the total left, total down equal to the total up. So at the end, we solve. Now you see we have 2T, right? Okay, so we solve the T and then we get the F, okay, dividing. So this in 1 by 2, we can solve by F over W equal to 10 delta. If not, you can use that T is equal to F sin delta and put into the formula and we can get the answer. Okay.
Consider a crate of weight 50 Newton placed on a smooth inclined surface. Find the horizontal force F that must be applied so that the crate remains stationary.
The horizontal force F can be calculated by using both the vector addition method and by resolving forces in x and y direction. Using the vector addition method, we can represent the forces W, F and R to form a closed triangle. Click Continue to follow the solution.
So we use the three forces. We draw the three force. The direction cannot change, but the position we can shift. No matter how, we can form two triangles. One of the triangle is a close triangle with the angle FRW with angle 60 and 30. 60, 30, and 90. That means that we can use the sin cos 10 because 90 degree.
Using sine theorem, r over sine 90 degree equals f over sine 30 degree equals w over sine 60 degree. F over sine 30 degree equals w over sine 60 degree. Therefore, f equals w times sine 30 degree over sine 60 degree, which equals 50 times sine 30 degree over sine 60 degree, which equals 28.9 Newton.
So from here, if the system gives us the W, okay, that means that the W is equal to 50 Newton. So this means by substitute in, we solve it, we get that the component of F is equal to 28.9 Newton.
Using the alternative method of resolving forces, the sum of the components of the forces along the x direction is equal to 0, and the sum of the components of the forces along y direction is equal to 0. Click Continue to follow the solution.
So we use the total force to left equal to the total force to right. Left equal to right, up equal to down.
Rx equals r cos 60 degree. Ry equals r sin 60 degree. Along x-axis, f minus r cos 60 degree equals 0, which implies f equals r cos 60 degree. Along y-axis, r sin 60 degree minus w equals 0, which implies w equals r sin 60 degree. Therefore, f over w equals r cos 60 degree over r sin 60 degree, which implies f over 50 equals cos 60 degree over sin 60 degree. Thus, f equals 28.9 Newton.
So this is another method to get the forces, which both of the method will get the same answer.
Click the play button and observe the action. A load of 1,400 newtons is pulled by the two persons as shown. Calculate the tension in ropes AB and AC when the load is in equilibrium. The tension in the ropes can be calculated by drawing the free body diagram representing the forces acting at point A. Draw a triangle with sides T1, T2 and 1,400 Newton and apply the sine theorem. Click Continue to follow the solution. T1 over sine 70 degree equals T2 over sine 60 degree equals 1,400 over sine 50 degree. T1 equals 1400 times sine 70 degree over sine 50 degree equals 1.7 times 10 to the power 3 Newton. T2 equals 1400 times sine 60 degree over sine 50 degree equals 1.5 times 10 to the power 3 Newton.
As a conclusion, in this lesson, a particle refers to a point mass as well as a rigid body where the forces act at the same point on the rigid body. A single force acting on a particle will never give rise to equilibrium. 3. For a particle to be in equilibrium under the action of two forces, the forces must be of equal magnitude but opposite in direction. For the particle to be in equilibrium under the action of three concurrent forces, the vector F1, F2, and F3 should be formed a cross triangle. If more than 3 forces, that means that no matter how much of the forces, the total of the vector of the forces must form a cross polygon. So you see, in general, a particle under the action of any number of forces is in equilibrium if the forces form a cross polygon. Okay, now we go to the next